Hello, welcome to topic number 5 for Unit 1. This time we are connecting the periodic table to electron configuration and the Bohr model. So previous lesson, I made sure that you learn how to draw the Bohr model and learn the electron configuration the difficult way because I want you to remember it and have a good foundational memory of the electron configuration. And once we make all the connections and connect the dots, everything will be really simple, okay? So I'm going to ramble a little bit over here. This is more like a background story, okay? So for each energy level, there's a center nucleus. For the atom, there is a center nucleus, and then around it, there will be first, second, third, or fourth, fifth, seventh energy level, right? So doesn't really matter. Depends on what type of element it is. However, each energy level or shell can be broken down into smaller parts. So for example, we have orbitals. Single boxes will be called orbitals. And then a whole orbital, or the whole D block, or it is called a subshell, okay? So there's going to be, for example, if this is a energy level that contains up to the F subshell, then it will have the S orbital or the S subshell, and then the P subshell, D subshell, and then F subshell, okay? And then the whole thing will be the shell, or the whole energy level. That's what it is. And why does it have different boxes? Well, I made this slide a while ago, and I was teaching students about electron spins. So basically, electrons have different spins. So it will go in up and then down, and then up, 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 down, down, down to fill in by order, okay? This is called the Pauli exclusion principle, but we're not really going to touch it, and it's not really that beneficial for your understanding right now, because all I want you to do or to learn is there are different energy levels and there are electrons on there. That's it. We don't need to learn about this. So I'm skipping it, but if you are interested in this, or how the scientists figure out each orbital can only hold 2 electrons, I can put some extension links in my website, okay? If you want to request that. And then right here, for S orbital, they can only hold 2 electrons. P can hold 6. You don't have to remember any of the pictures. I'm just using this to explain, okay? The D orbital can hold 10 electrons because it has 5 different orbitals, and each orbital can hold 2, okay? And then the F orbitals, they can hold 14 electrons, so 2 each again, and there are 7 different orbitals, or 7 different shapes. So how to understand this one, I will again include a YouTube link. One guy on YouTube really explains this really good if you want to learn about this, but essentially it's like different wave functions. So right here, the S orbital has no node, the P orbital has 1 node, and then yeah, the node is the part that doesn't move when a string is like waving, right? So that's, yeah, it's not important. I'm just using this to explain it, but if you want to dive deeper into this, you can at your own time, but I'm not gonna need you to learn this for now. So to make our life easier, we can essentially divide the whole periodic table into 4 blocks. We'll have the S block, the P block, the D block, and the F block. So it kind of tells you, so if you ever forget how many electrons can the P block hold, just count on the periodic table. So S block, we got 1 and 2, and then P block, I got 1, 2, 3, 4, 5, 6. D block 1, 2, 3, all the way to 10, and the F block is 1 through 14. Okay, so that's the fastest or easiest way to remember this: S, P, D, F blocks and how many electrons they each can hold. If you forget, just refer back to your periodic table and count it. Super simple. Okay, right here, the energy levels is basically the periods on the periodic table. So right here, we have period 1. Let me start drawing. So we got period 1, period 2, period 3, 4, 5, 6, 7, and they're all the beginning of each energy level. Okay, so for example, if an element is on the 3p block right here, this element, we will know it will have at least 3 energy levels. If an element is on this block right here, I will know it has at least 6 energy levels because it's on period number 6. Okay, so these numbers 1, 2, 3, 4, 5, 6, and 7, those basically just tells you how many energy levels those atoms have. Really simple technique to remember. So really quickly, if I ask you, let's say oxygen right here, how many electrons or how many energy levels would oxygen have? So right here, we can see the picture. It has 2 rings, right? So on the periodic table, we know this is 1 circle up here. So H has 1 circle. He also has 1 circle. And then the next one will all have 2. So we have lithium, we got 2 circles. Boron, I got 2 circles. And then neon, I have 2 circles. They all have different amount of electrons, of course, and protons and the mass, but the energy levels will be the same. For example, potassium right here, it's on period number 1, 2, 3, 4. It will has 1, 2, 3, 4 energy levels. Even right here, when you're counting the energy levels, you cannot just count here blank. So for example, iron, this one, that's not energy level 1, okay? Even though there's nothing on here, you still have to count from the period on the side. So this is 1, 2, 3, and 4. And there you go. Iron should have 4 circles. Let's check. We have 1, 2, 3, 4. Okay? And these numbers on the side, some of the modern periodic table will have these numbers. They will tell you the amount of electrons on each ring. So this one, the first ring has 2 dots. Second ring has 8 dots. Third ring has 14 dots. And the last energy level has 2 dots or 2 electrons. Okay? So I do have a periodic table like that in my room. So when you're learning or when you're drawing the Bohr model, it makes your life a lot easier. So you don't even have to do the electron configurations. You just have to draw the circles and then fill in the dots. Super simple. Right here. Let's look at this. Let's follow along, okay? So for 1s, level 1s, that's the first energy level. 2s is right here in the S block. And then 2p is in the 2p block, period 2 p block. And then after that is 3s. And then after that is 3p. After 3p is 4s. After 4s is 3d. And then 4p. And then 5s. So it goes on like that. So if you look on the periodic table, it all makes sense. We have 1, 2, 3, 4, 5, 6. So it's basically just going by order. Okay. So the whole thing that we were following the rule for, this diagonal rule, is basically a summary of the periodic table. So this is a 1, and then 2s, 2p, 3s, 3p, 4s, 3d, 4p. It all follows the same pattern. Okay. So this is a really brief, quick lesson to help you make the connection between electron configuration, Bohr model, and the periodic table.